Hi, this is just a quick video to help you out a little bit with the data collection project for Chapter 4, specifically with Part 9, how to test whether or not the R you get might be the result of random variation using StatCrunch. This is something we did not do together in class, so I wanted to show you an example of what it looks like. So I'm going to go ahead and just show you quickly some of the steps that I did on a report, and then we'll get to that step. So you can pause this and read the details if you want. But what I'm doing here is looking at the relationship between what row number a student sits in and what their final exam score was. And my expectation on that, just based on stereotypes, not necessarily my own belief, is that the good students sit up front and the slackers or the bad students sit in the back. And if that's really true, then if your row number 1 being in the front was low, you'd expect high test scores. And if your row number was high, like in the back, like a row 6, you might expect bad test scores. So that was the stereotype I was going off of. So I was expecting, I don't really believe that so much, so I was expecting maybe a weak to moderate negative linear correlation between row number and exam score. And then just kind of described how I collect the data, how I used a normal class day to get the row number, and then paired that up later when they took their final exam. Again, you can look at the details of how I write that out if you want. I entered the data into StatCrunch, row numbers and final exam scores, and then I did a screen capture and brought that over into my report and do the regression like we did in our tech project, bring in the screen capture of the graph with the line drawn in, which is kind of the page 2 on your regression window. So after you get this, just click on the right arrow to see the other page. And I just want to point out how it turned out. So I got a correlation of negative 0.11778139. So I guess the first thing I'd say is that supports my theory, right? I thought there would be a negative linear correlation. However, it doesn't support it really strongly because it's not close to -1, it's closer to 0. So if I was going to interpret that, I'd say something like there's a very weak negative linear correlation between row number and final exam scores. So one of the things we talked about in section 4.3 and 4.4, I guess mainly in 4.4, is that if the correlation's too close to 0, we're worried that in the population, if we were to apply this to all students, not just this random sample, the correlation might be 0. So we're trying to wrestle with the idea of if we get a negative correlation, but it's weak, does that mean there is a weak connection between the variables, or is it also plausible that there's no connection at all and the reason we got this negative was just a random fluke? And part number 9 of our DCP is to investigate that, and that's not something we did in class, so I want to show you how that works. First of all, if you just read this, you're not going to know what to do with that at all. You need to look at the next page, which gives you detailed directions on how it works. So the first thing is to create an applet that does a randomization test on your correlation. So you'll want to follow these steps so you can read through them, but I'll show them to you real quick. With your data in there, you want to go to applets and resampling and randomization test for correlation, and then just set your 2 variables, row number and final exam score. And then click compute, and that creates an applet that we're going to use to test whether this weak negative correlation we saw could just be the result of random variation in our sample, as opposed to no, there really is a connection where higher row numbers mean lower scores on average. So the way we do that is right now this data is paired in a natural way. This is some student, maybe Greg, whatever. He sat in row 6 most days, and on the final he got an 84. And then here's Nancy. She usually sat in row 2, and on the final she got an 80. So these two really are an ordered pair. They go together because they are a specific person that they're both assigned to. When I click on one time, what StatCrunch is going to do is randomly assign these test scores to one of these row numbers, which means they lose all of their real connection. It's just a random connection now. And if you randomly connect a y value to an x value, you should lose whatever connection is there, and the correlation should become 0. However, there will be some random variation in there that usually sets it off from 0 a little bit. So let's click random, or one time, to see what happens. So you see those move. So that did the random pairing, and then it drops the correlation in. It's kind of close to 0. If you want to know specifically what it was, you can click on the number 1 that just came up, and that had a correlation of negative 0.08. So again, it was negative like ours, and it was kind of weak, but this time I know that's not a real connection between the variables. It's just a random variation number. So meaning that these row numbers and exam scores don't fit together. They were just randomly assigned to each other. The correlation should theoretically have been 0, so anything you get away from 0 is just the result of the random chaos that created in that pairing. So let's do it again and see what it looks like the next time. So another mix-up, and then another correlation, and it'll drop in. So this time it was positive. So it's not surprising that some are coming out negative and some are coming out positive, because this is not a real connection between the variables. It's just random. So half the time it should be negative, half the time it should be positive, and in the end it should be centered around 0. But what we're interested in is it a common thing to get a negative correlation as big as ours, meaning big away from 0, or even further to the left, which would be even a bigger negative correlation? Is that a common thing to happen just due to randomness? So let's get 5 more of them. And what we see is the ones that are red are farther away from 0 than our number was. The ones that are this grayish were closer to 0 than ours were. Let's get 5 more. And so far, it seems like it's pretty common to get a correlation that's as big as our 117781, which is from the real data, or bigger, just due to random variation. Now you can bring in a bunch more by clicking the 1,000 times button. So I'm just going to do that a bunch of times. I think it just tells you to do it 3 or something, but the more you do it in a way, the better. And let's look at the directions again now that we've generated all that data. So we clicked 1 time, and then we clicked 1,000 times. It says 3 times, but if you do it more, that's not a problem. And then it says to capture that window. So let's go ahead and do that real quick, and then we'll look at the analysis choices. So there it is. I'm going to use Snipping Tool to capture it. Sometimes when you try and use the StatCrunch directions, they don't work good with Google Docs or something. So I'm going to pull up the Snipping Tool. I've got an old graph here, so I will click on New. The screen will go gray, and I can capture this report. You don't really need the options part, but you want all the other output. So all of this, I'll capture that, and then Control C, and I can go ahead and get that out of the way. Go to my report, go down to number 9, and drop below the number and do Control V to bring that in. And then the next just becomes a multiple choice following the directions, but you just got to make sure you understand what those directions are asking you to do and to think about what that means. So just wanted to guide you through that at least once. So okay, it says determine the chance that your original correlation R is just the result of random variation by doing the following. So in the graph window of the applet, it'll show the result of your randomizations. It's counting the number and proportion of times that a randomized correlation was further from 0 than yours, so I mentioned that already. If you originally suspected a positive correlation, and that's what your data produced, then circle the proportion or above. If you originally suspected negative, then and it turned out that way, do or below. If you suspected positive or negative and it came out the opposite, then add them both together. So let me show you those real quick. Let me make that bigger again. A little more readable. So I expected a negative correlation. That's what I said at the beginning of my study, and then I got a negative correlation. Because they match, I'm going to circle the proportion on this line. Proportion of the times I got correlations from the random pairing that was at negative 0.11781 or below. That's this red part of the graph right here. And the proportion of times that happened is right here. So that's the number that you'd want to circle. 0.3246, or as a percentage 32.46. If I had originally expected a positive correlation, then because it came out negative, I would go with the combined total. So if it came out, you expected positive and you got positive, use the positive line. If your original theory was negative and the actual data came out negative, then do the or below line. And again, if you suspected negative and it came out positive or vice versa, use the total. So that 3246 would be the number. Now it's just a matter of thinking about, all right, so what does that mean? Okay, so let's go back here. It said to circle that, so we would do that. And then it says this represents the chance that your original correlation R was just the result of random variation. So what I'm going to think about there when I look at that is, okay, there's a 32.46% chance that if there was no link between row number and test scores, I still would have got a negative correlation like mine, or even stronger. And so that's a pretty high chance that it's just random. So what we said on our last test is our default explanation for the way things turn out will be random variation, as long as there's a decent chance that's true. So it seems like if there's a 32% chance that data that was not connected would have a correlation this big or bigger, then we're going to stick with maybe it was just random and my variables are not correlated. So let's go see that option here. Our chance was 35-ish%, so that was more than 5%. So we're going to write this part right here in our report. We're going to conclude that it's reasonable that the variables of row number and final exam score are actually not linearly correlated, which means my original theory is not being supported strong enough from the data for me to have considered like that I've sort of proven that. So that's the way mine turned out. What you're really rooting for is for this number to be under 5%, because that will support that you were correct in your theory. So if this had been 0.032, then I would come down and say, okay, that's less than a 5% chance. So I would write in my conclusion that my variables, and I would always specify those, so that the row number, so let's say it was 0.03, 3%. I would conclude that the row number a student sits in and their final exam percentage really do have a negative, that's the one I would choose, linear correlation, because that was the theory I was trying to show. So that's a quick idea. Hopefully that gives you a little bit more than just reading it, and you see how it works and which numbers that you're supposed to use. Sometimes students use the wrong numbers in the report, but you're looking at these proportions here, and again thinking about which one to choose. If you suspected negative and your actual correlation came out negative, and the actual is referring back to what you got here. Okay, so if you were expecting a negative and you got a negative, use this line. If you're expecting positive and got a positive, use this line. If you got expected negative or positive and got the opposite in your data, use the total. And then pick one of these two conclusions based on whether your percentage in that proportion was smaller or less than 5%, and make sure that when you talk about the variables, you specify what the variables were in your problem. Alright, so there's a look at how that works.